This is the third in the series of debunking FlatEarther flyer. On earlier videos, I explained and debunked their point, airplane level flights, and water is a natural level. In this video, we will talk about point 3 on the flyer I have. Science says is stationary. Huh? I guess it's supposed to say stationary. Well, I make so many spelling mistakes myself that I shouldn't throw rocks. Moving on. Every scientific experiment has proven Earth is completely stationary. The Sun, Moon, and stars move around polar center above us, followed by research North Star, Michelson-Morley, Sagnac Experiment, and Airy's failure. It also has an image that seems to show the Earth being stationary, with stars above moving and making an almost perfect circle. Well, there is a lot to talk about here. After discussing the image, we will go through all the experiments they mention. There will be timecode in description. But before we begin, have you ever experienced the following phenomena? For example, when you are on a train, the objects far away seems to move relatively slower compared to the objects close to you, for example, railway poles. Well, things appear to move slower when they are far away because they seem smaller and take longer to cross our line of vision. Likewise, they appear to move faster when they are close by because they seem bigger. This is called parallax. So, if you only look at the object far away and ignore every other details, you might come to the conclusion that indeed you are moving very slow. But that conclusion would be incorrect. This is also one of many problems of geocentric model. We created a model where Earth is in the center and the remaining celestial bodies orbit around us. Oh yes! But then, for every single of these heavenly bodies, we had to ignore the rest and had to come up with ideas like epicycle, which is orbit within orbit, to explain various problems. This went on for a while until 15th century, when we just gave up and accepted the fact that Earth is not the center of the universe, thanks to Nicholas Copernicus. Just like our train example, we can't just look at one star that fits a particular narrative. When you're in the northern hemisphere, if you observe the north sky, it would appear that the stars are moving counterclockwise around a point in the sky where you have Polaris or the North Star. But when you move to equator, some of those stars are no longer visible, and the stars seem to travel from directly east to west through the sky. When you move to southern hemisphere, you can no longer see Polaris, but don't feel bad. You get to see the Southern Cross, which is not visible to those north of 35 degrees north, and the stars would now appear to move clockwise. On a flat globe model, this phenomena cannot be explained. There is no reason why someone in southern hemisphere not be able to see Polaris and vice versa, where in a globe model, it makes perfect sense, as people in southern hemisphere looking south is looking at the same part of the sky with Southern Cross. Now, what is so special about Polaris or North Star? Well, it is not the brightest. It is actually ranked 46th brightest star known today. It is not the oldest, nor is the farthest. What makes it special is, it's situated essentially above Earth's North Pole. And it is pretty far away. How far? Well, it's estimated to be around 433 light years away. Just for comparison, light only takes roughly 8 minutes to reach from Sun to Earth. Polaris won't be the North Star forever. Thanks to axial precession, which is the motion of Earth that causes Earth axis to trace out and imaginary circle on the celestial sphere every 26,000 years. From the northern hemisphere, there are 30 visible constellations. 5 can be seen all year, where the others appear seasonally. For example, Virgo can be seen from March to July, whereas in southern hemisphere, the constellation can be viewed in the autumn and winter months, though it will appear upside down in comparison with the northern hemisphere. There is one more thing to talk about here. Remember the stellar parallax? This is the apparent shift of position of any nearby object against the background of a distant object. One way to explain it would be to use this simple example. Hold a finger in front of your nose, and then alternately close one eye and focus at the finger with the other eye. The finger would have appeared to have shifted in position. Now, as you move your finger away from your nose, the shift would appear smaller and smaller. Now imagine your finger being a star, very far away. And your left eye is where the Earth is left from Sun compared to the star, and your right eye is the Earth's position when it is right from the Sun. Using this method, we can calculate the distance to your finger or the star. What does all of this mean? Well, for some stars that are very, very far away, like Polaris, it would appear to be still. But obviously it depends on the accuracy of the measuring device. For some constellations that are visible throughout the whole year, like Draco or Ursa Major or Minor, can you imagine what kind of trail they would leave on a time-lapse video? How about the ones that are visible seasonally? This hopefully explains the image and the part regarding research for North Star. But what does the polar center above us means? When used in geographic term, well, a polar circle is a conventional circular line referring either to the Arctic Circle or the Antarctic Circle. And we know the sun rises or comes into view from east, then it sets on west or goes away from view. So honestly, I don't understand what polar center above us means. I'm just so confused. Now the remaining research, Michelson-Morley, Sagnac Experiment, and Airy's failure. At one point in history, we discovered that sound needs a medium to travel. Let it be air, water, or other medium. And that it wouldn't travel in vacuum. From that we theorized that, light being a wave similar to sound, it must also need a medium. As we know there is no air, water, or such material in the vastness of space, there has to be something for the sunlight to reach Earth. And we call this theoretical medium ether. Once we figured out how to calculate the speed of light, physicist A. Michelson and Edward W. Morley performed an experiment in 1887 that came to be known as Michelson-Morley Experiment. At the center was a half-silver mirror, so this would reflect half the light and let the other half through. From this center, equal distance away was 2 mirrors. Finally, one of the remaining axes was the detector and the light source in the final one. The idea is, light would hit the half-silver mirror, then half of it would be reflected and the other half would pass through. Then it would be reflected back and combined to get to the final detector on the right. A basic explanation of waveforms here. The undisturbed positions of particles when they are not vibrating is called rest position. The highest point above the rest position is called peak, and the lowest point below the rest position is called trough. If you take a waveform and combine it with itself, well, then both of these are in phase, and the waveform would be accentuated. This is called constructive interference. Now suppose you shift it enough, so when you combine, the peak of one of the waveforms is in the same place as the trough of the other waveform. Well, if they cancel each other, you would have a flat line with an intensity of 0. Anything between? We will see an interference pattern where intensity would be between the in-phase addition and the out-of-phase addition. Now, as the Earth is moving, and suppose it's moving from right to left in our illustration, that would mean the light would deviate more from horizontal axis to vertical axis, as it would get a boost in one axis and resistance in the other due to ether flow. And that will result in a different phased wave once combined than initial source. We don't even need to measure it against our initial source, as by simply rotating this device, we should be able to see the variance. So as far as principle goes, it is pretty sound. However, they could find no discernible phase changes. Well, what does that mean? Either it means maybe light doesn't need a medium to travel and ether is not real, or the Earth is stationary. It took Einstein to come along and explain that light is not like sound and doesn't need a medium to travel through. French scientist Georges Sagnac in 1913 performed a similar experiment with his setup called a ring interferometer to prove the existence of ether. This time, the beam of light is split with a half-silver mirror, and then both beams are made to follow the same path but in opposite direction. Finally, those beams were combined. The interference pattern is first noted at a rest frame. Now, this whole device is spun, and during this, he noticed the pattern to be different. From this observation, Sagnac came to the conclusion that it was the ether that caused the speed change in light beams and claimed that ether is also relatively static. But what is really happening? And why did both of these experiments seems to indicate different result? Michelson-Morley earlier demonstrated that if light travels through ether, then Earth is not orbiting. And what did Sagnac observe? Well, he observed light having different velocity, which he attributed to ether. From those two apparent facts, flat earthers come to the conclusion that the Earth is stationary. Scottish scientist James Clerk Maxwell in 1864, even before Michelson-Morley experiment, demonstrated light to be an electromagnetic wave and was able to calculate the speed of light. Einstein noticed that this equation didn't take into factors like speed of source, the observer, or the medium. This led to Einstein's eventual musing on the theory of special relativity, which he broke down into the everyday example of a person standing beside a moving train, comparing observations with a person inside the train. He imagined the train being at a point in the track equally between two trees. If a bolt of lightning hit both trees at the same time, due to the motion of the train, the person on the train would see the bolt hit one tree before the other tree, but the person beside the track would see simultaneous strikes. In simple terms, that theory states the laws of physics are the same in all inertial frames, which means Maxwell's physical law for the speed of light is also the same in all inertial frames. And inertial frames simply means a body is at rest or moving at a constant velocity and not accelerating. This is what Michelson-Morley and, as we'll find out later, Airy had shown us. 2 years before Sagnac's experiment, German physicist Max Born wrote the first description of the Sagnac effect in a framework of special relativity in 1911. By continuing the theoretical work of Michelson, Van Laue confined himself to an inertial frame of reference and in footnote explained with equation and concluded that this interferometer experiment would indeed produce the same positive result for both special relativity and the stationary ether. Well, for Sagnac's experiment, Max von Laue concluded the beam traveling around the loop in the direction of the rotation will have farther to go than the beam traveling counter to the direction of rotation. This is because during the period of travel, all the mirrors and detectors will have moved slightly towards the counter-rotating beam and away from the co-rotating beam. As the distance changes, the beams will reach the detector at slightly different times and slightly out of phase, due to which we would get a different interference fringes. Sagnac's effect is real, and in fact, we use this effect to build ring laser gyroscope that is used in navigation system. In fact, it is so accurate that this gyroscope can measure the rotation of Earth.
A 15-degree-per-hour drift.
Finally, Airy's failure. English mathematician and astronomer Sir George Biddell Airy tried to prove the existence of ether drag. To understand his theory, think of the scene in Netflix Witcher where the mages capture lightning in a bottle. The lightning or photon is coming down perpendicular to your bottle or telescope. Now, instead of standing still, what happens if you're moving? Well, suppose there is this medium ether that is around us. Now, case study 1 would be, as the Earth is moving, it is dragging the ether with it, which means even if you're moving, the photon beam is also dragged with the ether and would still be perpendicular. Earlier, we talked about stellar parallax. Well, in 1720s, James Bradley tried the very same experiment to determine the distance to a star. Unfortunately, due to the limitation of equipments Bradley had available to him at that time, he couldn't calculate the distance. However, he did find out that he had to shift his telescope at a slight angle. This also meant case study 1 of Earth dragging the ether is not possible. Comes in case study 2, that ether is not dragged with Earth. Now, based on your movement, the relative velocity of that light beam to you changes and becomes diagonal. You experience the same phenomena where if the rain is coming down straight, you hold your umbrella straight up, but if you start running, you would then angle your umbrella to make it perpendicular to relative rain direction. Great! So you angle your telescope so the light beam is coming in perpendicularly. But if you're going around in an orbit like our planet, that would mean in 6 months' time you'd be facing the other way, which means you'll also have to tilt your telescope the other way. And yes, we do find that we need to tilt our telescope slightly at different times of year to see the same stars. We call this phenomenon stellar aberration, an astronomical phenomena which produces an apparent motion of celestial objects. Bradley conceived of an explanation where he considered a distant star is motionless relative to the Sun and the star is extremely far away, so the parallax may be ignored. He calculated the equation to find apparent angle, and true angle are related using trigonometry. If we consider true angle to be 90 degrees, then we can simplify the equation to be the offset angle equal to velocity of the Earth divided by the speed of light. Called the classical explanation, this formula is far less accurate than relativistic formula. But in the limit of small angle and low velocity, they are approximately the same, within the error of measurements of Bradley's day. Knowing that light slows down in water, Airy theorized that the presence of water slowed down the light's movements through the ether and reasoned that this slowdown shouldn't affect the components of the light's velocity caused by the motion of the Earth, and this would presumably change the angle of the light. So in 1817, he filled a telescope with water and expected this stellar aberration to be different. But in reality, he detected no change, and thus this experiment is known as Airy's failure. From this demonstration, flat earthers jumped to the conclusion that the Earth is stationary, otherwise Airy should have detected some change. Well, from Airy's description of the telescope, the length of the water column was 35.3 inches. Next, light speed. We use a ratio for speed of light through different medium compared to its speed in a vacuum. This is called the refractive index of a medium. For air, it is roughly 1.0003, and for water, it is 1.333. What that means is, if that part of telescope was filled with air instead of water, well, in water it would take 3984.97 picoseconds, where in air it would take 2990 or 80 picoseconds. That is a difference of 994. Well, let's call that 1000 picoseconds or 1 nanosecond. That is 1 billionth of a second. That is the kind of precision we are talking about back in 1817. Next, we need to address the refraction. Even if the equipment wasn't sensitive enough for the speed, we should have seen the refraction, right? This brings us to Snell's law. This law, eventually named after Snell, was first accurately described by the Persian scientist Ibn Shahl at the Baghdad court in 984. Simply put, a ray of light would bend when it travels from one transparent medium to the other. There are a couple of things we can measure here. First, we need a normal line. This is the line that is perpendicular to the surface of both mediums. The angle between the incoming ray or incident ray to this normal is called incident angle. Finally, when the ray bends or refracts, that angle to the normal is called refracted angle. Snell's formula states incident index times sine value of incident angle is equal to refracted index times sine value of refracted angle. Given that, we calculate that if sunlight hits a swimming pool at 35 degrees to the normal, we would get a refracted angle of 25 degrees. Pretty cool, right? Back to Airy's telescope. Remember, the whole point of tilting is so the photon would appear to be perpendicular to the telescope, which means our incident angle is 0 degree. Thankfully, both sine and arcsine value of 0 is 0, which means our refracted angle is also 0, i.e. still perpendicular. Hopefully that explains why Airy didn't see any changes in stellar aberration. Quick recap. Airy demonstrated with ether as a medium, it is definitely not being dragged by Earth. Michelson-Morley experiment that demonstrated with ether as a medium, either it was dragged with the Earth or the Earth was stationary. As Airy demonstrated ether was not dragged, then the only other explanation is Earth is stationary. Finally, Sagnac, who demonstrated how light takes longer path on a rotating device, and he attributed to another proof of ether's existence. I can see how flat earthers combine these findings to come to their conclusion. But let's be fair. Scientific method tells us to set aside our biases and look at the evidence. So let's give this a fair evaluation. Can Michelson-Morley experiment be taken as evidence for non-moving Earth? Well, yes, I think it can. But then again, we also have to look at all the other evidences. If the experiment starts with an assumption or a bias, then the result may be tainted and may have other explanations. Watching the phases of Venus indicates that Venus is orbiting the Sun, which would then mean on a geocentric model, Sun is orbiting the Earth and Venus is orbiting the Sun. Moons of Jupiter shows us that they are orbiting around Jupiter, and Earth is in the center of everything. Go outside at night and find out where Mars is with respect to the background stars. Do it again the next night and you will notice that it is in a different location with respect to the background stars. In fact, all the planets do this. That's how we know they aren't stars. If you keep tracking the motion of Mars, you will notice that it moves to the east, except for some special times. Occasionally Mars will move west for a short time before once again moving east. This is called retrograde motion. On geocentric model, where Mars orbiting the Earth, this motion cannot be explained, where in a heliocentric model, it makes perfect sense. Then we have stellar aberration. Yes, that is a proof for the orbit. In February 3rd, 1851, a 32-year-old Frenchman who dropped out from medical school and dabbled in photography definitively demonstrated that the Earth indeed rotated, surprising the Parisian scientific establishments. Acting on a hunch, Leon Foucault had determined that he could use a pendulum to illustrate the effect of the Earth's movement. He called together a group of scientists, inciting them with a note declaring, "You are invited to see the Earth turn." Foucault hung a pendulum from the ceiling of the meridian room of the Paris Observatory. As it swept through the air, it traced a pattern that effectively proved the Earth was spinning about an axis. Note that I have skipped proofs like satellites and photographs, as flat earthers often claim those are photoshopped. So I basically focused on tests you can do yourself at home. First of all, we can all confirm that there are certain stars we do not see from our current location. Depending on where we are, we can also confirm some stars are visible only during a certain time of the year. Finally, we can also verify that we have to slightly tweak our viewing angle throughout the year to keep a star in center and proving stellar aberration. The other do-it-at-home example we mentioned, we get some more data points against geocentric model. Then if you also put up your own pendulum or maybe get a ring laser gyroscope using Sagnac Effect, you can get further proof of the orbit. So can we say this slide is thoroughly debunked? Well, that's all for this video. It was a bit long, but I felt it's only fair to talk about all their points instead of chalking it all up to ether in one sentence. I do hope you have enjoyed it. If so, can I please ask you to like the video and maybe leave a comment to feed the YouTube algorithm? As you can also see, I'm at a 2-digit subscribers count. So if you can also subscribe, that would definitely help this channel grow and would be thoroughly appreciated. Have a safe day. Signing off.